And this is Nicole Testa-Boston, the Deputy Director at FIATech. And we're very glad you could join us today. We're going to have slightly unusual or a different topic for us at FIATech on innovation in creating large underground structures. We've had a lot of interest in this, and we're thrilled that James and Chris are able to take some time today, both over in Europe, to join us and discuss what the work that they're doing. Before I go ahead and introduce them, though, I would like to go over with those of you who may be using the GoToMeeting, GoToWebinar system for the first time on how to use that. That toolbar you're seeing is unique to you. To move it off of your screen, you can hit the orange arrow button at the top. That will minimize it and give you an unobstructed view of the presentation. You'll also note that due to the number of attendees that your audio is muted. We do, however, encourage questions and comments and clarifications that you may seek. So please use the Questions tab on that toolbar. At any time during the presentation, you can type in a question or a comment or something you'd like further clarification on. Those will go directly to me, and as time permits, we will answer those at the end of the session. And if we do run out of time, we'll follow up with you following the webinar. Last but not least, we will be recording this webinar, and we'll be posting it on our website at fiatech.org in the next day or two, so you can share this with a colleague or review it again at a later date. So with that, I want to go ahead and thank both James and Chris for joining us and give a short introduction. James Thompson, he's been involved with the horizontal construction using jacking methods for pipes and structures for over 40 years. Initially, he pioneered pipe jacking methods of pipe installation and subsequently jacking of large box structures and multi-tier methods. In 1979, he established Jason Consultants Group, an international consultancy in the underground infrastructure, which included design and management of many projects involving tunneling, micro-tunneling, pipe jacking, and jack structures. In 2003, he sold the Jason Group to his colleagues, and in 2007 formed the Jack Structures Group with colleagues who he has worked with previously. The group undertakes conceptual design, temporary work design, and construction management for jack structures of all types. He's developed a number of patents in the field, including jacked arch and jack deck methods, which provide improved methods of installing non-disruptive underpasses. James and I go way back to our days at the American Society of Civil Engineers and SURF. He's a chartered civil engineer, Euro engineer, and he's a member of the Institution of Civil Engineers. Joining him is Chris Howe, who's also a civil engineer and a member of the Institution of Civil Engineers. He has over 40 years of design and construction experience associated with infrastructure projects throughout the UK and overseas. He's been instrumental in the successful completion of over 20 jack structures for major new underbridges and tunnels beneath live rail and highway infrastructure. He has worked with multiple discipline design teams dealing with planning, teamworking, civil, structural, and geotechnical engineering, construction safety, predictability, and R&D. He's had a significant involvement in the Boston Central Artery I-90 involving 3 large jack box tunnels up to 100 meters long beneath 7 interconnecting live rail routes. The method was promoted as an alternative to the project manager's solution of top-down construction. So once again, we're looking forward to this presentation, and we'll go ahead and get started. James, I'll turn it over to you.
Thank you very much. I'd like to first of all say good morning to all of you, and I hope that we keep you interested for a little while. Some of what we are now doing is pretty innovative and pushing the boundaries, and of course pushing the boundaries is our sign, as you'll see on the first slide there. Okay, just quickly to tell you that Jack Structures has worked on and is working on a number of different types of projects, and many of them are quite different one from another, and each project is unique, so there's no one set of things that one does. You actually have to be very specific to the site and to the ground conditions, which are all important. Anyway, let's get started and look, and I'm going to start with some of the background and the development of jack structures. One of the things that what we now know today is that 50% of the world's population has moved into urban areas. And it's predicted this will be increased even to 70% by 2070. Now, taking a look at this slide here, you will see that we're getting pretty congested in a lot of these urban areas. And space becomes a premium, doesn't it? Expensive, not much of it, and it makes people's lives not very attractive if they don't have the facilities, leisure and public areas. And somehow we've got to try and find space in these big urban areas. And developing underground is one possibility. Now, there's nothing new about developing underground. As we all know, we've all traveled on metros and undergrounds, and these obviously are very valuable in that they provide a method of transporting people, many millions of people each day, and reducing vehicle use, which is definitely beneficial. Now, also, not only have these developments been to put in rail tracks, underground rail tracks, but many of the stations have taken the opportunity to develop commercial shopping concourses. And if anybody goes to Hong Kong or a lot of other parts of the world, you will find that they include very substantial shopping facilities as part of the design. So already people are going underground. It's just how and where. Here we've got some scenes. These are taken actually in Seoul and Korea, the two on the left, because there are huge areas of underground shopping and so on, and you can walk all over the center of the city without ever coming to the surface. It all interconnects. And of course that's also true of other cities. I mean, cities like Edmonton, I know, and even if I believe it right, Texas has a lot of underground passages that allow you to go around. Houston has a lot of these underground passages that you're allowed to pass comfortably. And of course they have great advantages in many ways because they're very safe, there's no traffic problems, and they're comfortable in all kinds of weather. I mean, in Seoul it's because it's very cold in the winter, in Houston because it's very hot all the time. Okay, developing underground, when you think about it, there are lots and lots of the facilities that are presently on the surface could be moved underground. Some of them do, of course, like the parking, which I show there. But lots of sports facilities could be. And all these are underground shots. Of course, one of my favorites is the one on the left, the wine cabins. I would definitely be interested in any projects of that kind. But all kinds of storage. I mean, underground reservoirs, for instance, would free up space at the surface. And it's an interesting one is the computer control room to the right there. No, over and above that, one gets military facilities, and lots of other things are possible. So if we look at how these facilities have been constructed to date, we obviously have modern tunneling techniques, which we've got up to about 15-meter diameter, and they can be installed in all kinds of ground conditions using pressure balance machines, and are widely used for metro installations. Now, a lot of the examples I showed you on those slides previously were undertaken in competent rock. I mean, there's been a great number of underground facilities installed, for instance, in Helsinki, which is on competent rock and allows these things to be excavated out safely. If you want to do this kind of construction in areas which are not competent rock, in soft ground, etc., you have to, up to now, most of it has been done requiring large excavations, from the surface and then subsequent reinstatement. And that obviously involves considerable surface disruption. And what we're trying to do is eliminate 3 by constructing things in alluvial to ground soils, etc., which don't disrupt unduly surface facilities. Let's just talk a bit about horizontal construction. I've got to tell you here and now that I had nothing to do with developing or formulating the first ideas on jacking pipes. That was done in the United States around about 1890, as far as I can tell, and they were jacking cast iron pipes into the ground to make culverts. Well, I picked up on these ideas back in the 50s, and it's developed immensely all around the world. I mean, we started with jacking pipes in, with men working inside them, but it wasn't long before we got into microtunneling, which allowed machines to do the excavation, and virtually no men were working down the pipe. They were all working in the pit, just adding pipes as each one was pushed in as the tunneling machine advanced. And this has become an incredibly important method of tunneling in the last 40 years and allowed a whole range of pipes, for instance, in smaller diameters, which were too small for men to work in, to be used. But machines can do it without anybody having to be there with them doing the excavation. We won't go into that in too much detail because it's a whole subject of its own. But let's move on, because I'd like to talk about things like jacked horizontal construction of large structures. And way back in the 40-odd years ago, you will see that down at the bottom is Brent Cross, UK, and that was one of the very first jacking jobs I did. The principle of box jacking is shown up on the right-hand side there, and you precast the box at the side, as you can see, and you jack it into position with excavation going on, proceeding at the face, and as it's excavation, you keep pushing it forward until you've got the thing into its final position. That Brent Cross job was to open up a huge shopping centre, and the only access was under a main highway, and so that's what we're jacking under there. Now, there's been we've been involved with maybe about 80 jobs subsequently, and one of the big ones that Chris was particularly involved with, I also had an involvement, but not to the same degree as Chris, was the Boston Big Dig, where they jacked huge boxes through under the rail tracks, as mentioned in Chris's introduction. However, that wasn't the easiest job in the world, because the ground conditions were pretty difficult there, and they had to freeze everything. And that did cause some minor some problems, let's put it that way. However, while I was working on this business with one of the major contractors in UK, I came up with the concept of actually creating modular construction. And there you will see that the first thoughts of it. The idea was to jack in a series of boxes to form the abutments and the central pier. And you can see the concept up on the top there. And on the left-hand side, you can see an actual example of what was done. And finally, at the bottom there, there's a finished bridge at Wandsworth under a large number of rail tracks, because it's very close to the main hub station, so there were a lot of tracks coming in. Well, in that case, we weren't able to do everything without disrupting the railway. We actually had to have a possession over the weekend so as the deck could be placed on top of the units, but it did mean a greatly reduced possession. And finally, one of the other methods that is used, and I know it's been used in the USA, is what we call the advanced support structures, is by driving a canopy of tubes. You can do that by horizontal boring, by ramming, or microtunneling methods, and then you work inside that because you have the support. But you do actually have to provide additional support, because those tubes are longitudinal. They won't stand up by themselves without framing. Now, I'm going to move on to some of our recent innovations. Firstly, the jacked arch, and then the jacked deck. And to kind of simplify on the concepts, both of them are based on breaking down the insulation into control components, using high-quality precast units. And maybe what is the clever bit is combining tunneling with deck and arch units, or deck or arch units, jacked along a slide path. So you're providing, as you go, by either method, a full structural lining at every stage, which is a great advantage, as you can imagine, because we can't afford to have any collapses when you're putting one of these things under a railway. So these are the two concepts, and we've started to utilize these, and they are an improvement, we believe, on some of the traditional methods or some of the existing methods that are being used. And we're going to illustrate this by talking, or Chris is going to take over at this moment, and he's going to talk to you about the Cliffs End underpass, which is an example of where the jack deck was used. Now, Chris, I'm handing over to you, so you're going to have the keyboard and mouse. Have you got it? No?
James, just give me one moment. I need to unmute him. We were having some feedback issues.
Okay.
Okay, there we go. Chris, can you hear us?
I can hear you. I hope you can hear me.
Okay. You've got the keyboard now, Chris. You should have the keyboard.
I think you're still controlling it, aren't you, James?
Okay. Well, I am, but okay. Just a minute.
Otherwise, James, if you just want to advance the slides, that might be the easiest thing to do.
I'll just advance the slides. Okay, Chris?
Okay, well, good morning to you all, and as James indicated, this section of our presentation shows highlights, in fact, of a 4-year cooperation between main contractor and Jack Structures during the development of the innovative solutions used to construct an extremely challenging new underpass beneath the existing mainline railway without causing any disruption to rail services throughout the construction period. Next.
Okay, I think I'm going to have to go on. Oh, there you go.
No, still on the original.
Okay. This is, you've got the layout there, Chris. You want me to go on?
I haven't, mine hasn't moved. I'm still on the first slide.
Okay, they've moved on my screen. Can you help us, Nicole?
Let me... Chris, how about if I make you the presenter? Can we try that?
Yep.
Okay.
If this is locked up? Okay. Sorry about that. I don't know why that locked up, but Chris, you should get a message here.
Yep, I've got the message.
Okay.
You can take over. Chris, can you see it?
It's got one ready. Show my screen.
Yes.
Not coming up yet.
Okay. James, can we try it with you again, since we had it working with you? You're going to have to accept it again and then show your PowerPoint presentation.
You are the presenter. Show my screen. You want me to hit show my screen?
Yes, James.
Okay, there we are.
Okay. And then you just hit the arrow button to move it forward, James.
Okay. Can you see it, Chris?
Yeah, go on, far away.
Perfect. There we go.
Great.
Thanks.
Okay, well, to introduce this project, I'm starting with an aerial view of the completed Cliffs End section of the new highway. Here you can see the underpass section through the village of Cliffs End, the railway intersection, and on the right the Kent International Airport. At 126 meters, it is believed to be the largest jack deck structure installed below live rail tracks in the world. The client was East County Council, the Highway Authority, and main contractor was a joint venture of Volker, Fitzpatrick and Hockteeth.
Okay.
Yep. Now this shows the scheme layout. The scheme provides 8 kilometers of dual carriageway and completes the A299 Thanet Way dualling that commenced in the late 1980s. Construction projects, they do take a long time. The final phase was completed ahead of schedule and within the £87 million budget. The main construction contract was awarded by the Highway Authority in August 2009. And just go back, James, please.
Just back, you want?
Yeah. Okay. The start of the contract was October 2009 with an official opening in May 2012. Just highlighted there is the actual location of the Cliffs End underpass. That's the large underpass we're talking about on that short section of highway in Kent. There were many constraints in the area, including the operational requirements of the airport, the built environment around Cliffs End, and an internationally protected area known as Pegwell Bay, all of which restricted the choice of route for the highway. The only route available was through the middle of Cliffs End, beneath the Fodes Hill as detailed, and the main London to Ashford railway lines, which created the most challenging structure on the project at Cliffs End. Now, just to give you a little bit more of an insight into the local environment, this is an aerial photograph before construction. The line of route is just being indicated in the blue. The construction operations obviously provided a formidable challenge, being constrained with 6 meters of overburden, heavily skewed, and in close proximity to the residential property you can see. There were a lot of main utilities, including sewers, substations, radio receiver masts, and Network Rail, who run Britain's railways. They were about to commence a new high-speed service to the new railway link at St Pancras International Station in London. And their rail operations were not to be disrupted during this construction stage. So the challenges were quite formidable. Next.
It's all right. There, I'm coming there.
Right, this shows the site, the construction site at an early stage of development. It indicates the 15-meter deep cuttings either side of the railway, and the challenge was to develop a technique which minimized ground settlement. At tender stage, the client issued a conforming design. This was based on a conventional twin large jackbox sections side by side. But due to various concerns relating to jacking capacity, controls on alignment, and the height of the open face, which could lead to unacceptable settlement, the team agreed to a different approach. That's the original twin box solution.
Yep, there's the alternative.
So these were the design alternatives that our team developed, and this was the tender proposal, which shows the jack deck on multi-level jacked boxes. Following award of the contract, the team carried out a number of technical reviews with value engineering, and coming in on the right-hand side is an indication of the final solution that was chosen for construction after value engineering. The modular foundations were replaced with large diameter bored tunnel within which reinforced concrete would form the abutment, and board piles would provide the support to the adjacent ground. So looking at the bored tunnel in detail, these provide horizontal space about 10 meters below the railway from which construction can be carried out safely without interruption to rail services above. The sketch just indicates the various elements of the slide path, the reinforced concrete abutments, and the board piles. All of those items were constructed from within that horizontal space provided by the bored tunnels. Later, during the subsequent deck jacking operations, a number of roof segments would be removed to expose the slide track, but that would be within the protection of the main tunneling shield. Now we moved on to just an indication of the earth pressure balanced tunneling machine used to drive two 126-meter long tunnels. Rail track movement was continuously monitored from robotic total stations, and a vertical movement was detected of only 3 millimeters, which was splendid work by the tunneling team. This was immediately followed by the installation of 530 450 millimeter diameter board cast in situ piles. Reinforced concrete pile caps were constructed, and that photograph on the right gives an indication of the installation of the reinforcement within the tunnel to form the foundations. And then finally, the figure 3 shows the top of the abutment in preparation for installing the very accurate slide track upon which the massive deck units would be installed. One important point at this stage is that quality control is essential throughout, with close cooperation to tolerances to ensure installation of the deck could be achieved. You get one chance in these projects to get it right, and even minor out-of-tolerance construction elements have to be rectified fairly quickly. The main slide track installed within the abutments incorporate a stainless steel sliding surface along which the jack deck bearings slide. The system consists of thick elastomeric bearings with a bonded PTFE surface with a total vertical load applied 50,000 tons. Flexibility is contained within the bearings, and the slide track installed to a tolerance level of plus or minus half a millimeter. The tunnels were completed within an 8-week program in 2010. Thank you, James. So now moving on to the actual deck construction stages. The underpass roof comprised 6 abutting precast concrete deck units, each 23 meters wide, 22 meters long, and 1.8 meters deep. Heavily reinforced slabs with short downstands. And between each abutting unit, an intermediate jacking station is positioned with a steel skirt to maintain support of the overburden as the units open and close during installation. The 6 massive jack deck elements were precast in turn at the rear of the construction workyard, as shown on figure 1, and they were moved up in sequence to the assembly area, shown in 2. And then the lead unit, figure 3, incorporates a mining shield with cutting plates designed to provide intimate support and contact with the open face excavation. 8 working cells provide space for the excavation plant and miners. Next.
Okay.
Oh, sorry. Okay, figure 4. Nearly missed that one. At the front of the deck downstand, there's an unusual extension in front of the downstand. This is to pick up the additional cantilever loads at that point in the shield to ensure that there's no overstress on the lead bearings in contact with the slide path. And the design of it is such that that lead shoe moves into the pre-bored tunnel on the slide track, and the clearance to the shield above allows enough area for miners to remove a number of the tunnel segments as the work proceeds. So again, you know, close tolerance, close attention to detail is very important at this stage. Next. So this is just a view of the pre-assembly area. The size of each deck unit required a casting yard some distance from the launch area, right in the back of the photograph. And then in sequence they were moved forward on temporary slide paths to an assembly area where the final fit-out could be undertaken before moving each unit in turn onto the launch pad. The actual casting yard was about 150 meters away from the shield entry point before going into the beneath the railway. Next. An essential requirement for large underground jacking operations is to maintain ground stability and reduce frictional resistance from the unit in contact with the ground. And it's been common practice when undertaking box jacking works to introduce what we call an anti-drag system between the top surface of the jack box and the overlying soil. At cliff's end, the general depth of overburden, being some 6 meters below rail track bed, is such that large-scale lateral movement of the ground was considered a very low risk. The shearing resistance at the sides of the ground block above the proposed deck offering ample resistance against the wholesale lateral movement. But lateral movement of soil at the interface between the deck and the overlying ground could occur due to frictional forces, and such migration as the deck is installed could be expected to contribute to settlement or heave on either side of the railway. And for this reason, an anti-drag system focused upon the need to mitigate ground migration. Figure 2 shows the sheets. They're stored in rolls in the roof of the front unit. These sheets are high-quality steel, 2 millimeters thickness, and they comprise 2 sheets per drag sheet in order to deal with the high tensile forces that are developed as the jacking proceeds. And at figure 3, the head wall anchorage system can be seen. This is the leading or the free end of the drag sheet. It's fed up through slots in the shield and then anchored back to the head wall above, so that when the deck unit moves into the ground beneath the head wall and under the railway, the sheets are gradually moved out onto the deck of the unit and remain static with the soil above. Lubrication is also included using bentonite or a high viscosity gel through grout manifolds along each unit. Next.
Sorry.
Okay, just looking at the jacking system, 2 jack assemblies were incorporated into the project. Rear jacking stations with a capacity of 7,000 tons, and intermediate jacking stations between each unit, also comprising 7,000 tons. The front jacking stations had a stroke of 300 millimeters, while the rear jacks had a long stroke of 2.5 meters. And the project requires a very sequential movement of units from the launch pad through to final completion. The operation of intermediate jacks plus the operation of the rear jacks result in an accumulated jacking load which is applied throughout the whole of the job, and that graph just indicates the total applied jacking resistance during installation. And in fact, the combined load at completion of the job was under 15,000 tons. But you've got to have a lot of reserve capacity, and this is what's required in the event that you might hit obstructions, or there may be some steerage requirements or some other unforeseen situation that you come across. Having sufficient jacking capacity in reserve provides a certain benefit. Now, just moving into the front end, the working end of the shield, This is a view just at the start of the shield going into the ground. You can see in the roof the drag sheet rolls and the beginning of mechanized operation in order to gradually peel the material from the excavated face and remove it to the rear of the unit. Ground conditions on this particular project were fairly competent chalk, but there was an alluvium type material called thanet sands and gravels, which were overlying the chalk and in fact did penetrate into the shield by up to about 2.5 meters. On the top corner of the shield that's embedded, you can see an indication of the thanet sand in that portion of the shield. And a later shot where the shield is fully penetrating the ground. The shield provides pressure which maintains support and mitigates any risk of movement of the ground during the continuous installation of these units. Each deck was installed in 7 days, each individual deck unit that is, with a turnaround time of about 3 days for installing the subsequent units on the launch pad, totaling about 10 weeks for completion of the 126 meters installation. And the final slide for me, James. So, a view of the completed job opened in May this year with quite a number of achievements. It was built 5 months ahead of schedule. It was built within budget. It was built safely. And most important, built without interruption to rail services. So on that final shot, I'll now hand back to James, and thank you very much for that section.
Okay, Nicole, do I have it?
Yes, you do.
Okay. I want to finish up this session by talking about some of the potential advantages of the jacked arch and the jacked deck concepts. It is specifically designed to work in all types of soil, I mean even quite difficult soils, because we have a number of advantages by using these modular systems we use. We do use small faces which are much easier controllable, and those access boxes access if we need to do any ground improvement, because you are working very close to the area where the main larger unit, the deck or the arch, will be put in. One of the major advantages, in my opinion, of this method, as opposed to systems like sprayed concrete lining, is that we provide a full structural lining at all stages. The whole of the excavation as it proceeds is fully lined with a completely designed lining which will not collapse. By breaking it down into units, we greatly reduce the exposed excavation face, and at cliff's end we halve the depth. If it had been a jack box, it would have been twice a deep face to hold up, and that is one of the big areas where you may run into trouble. The greater the depth of the excavation face, the greater the likelihood of collapse. Because we're running on tracks, we're absolutely able to guarantee installation both laterally and vertically, which is, again, quite an advancement over, say, box jacking, which, if it starts to move offline or level, is very difficult to steer away from, and we don't suffer from that problem. It reduces the potential for minimal for surface settlement. I mean, I'm not going to say we don't get any. You do get a small amount every time you do any form of work, because apart from anything else, you may get consolidation of the ground above without actually losing any soil yourself. We are now able to introduce and install much larger and longer structures than have ever been done before. Cliff's End, although it was the largest, by no means is the limit on the length of the structure we could put in, and we could certainly, we believe, go 200 meters if we were asked. And of course, what's important for a lot of the clients is that the reduced time of installation under critical facilities. Now, I believe there are lots of opportunities for creating underground space, and a whole range of larger and longer underground installations are now possible in a wide range of configurations. And I would point out that many cities are built on the edges of rivers next to the ocean and are not on competent rock. They are on alluvial type conditions, and so putting large structures underground is more difficult. But I believe we've got some potential answers. One of the things we've done is we've developed a number of possibilities for putting full metro stations in. And here's one example where we've used the top box with piles out of it and a flat arch. But there are others. We could use abutment and a flat arch. We've got the modular foundations there and the walls. You could easily arrange a full platform arrangement if you wished. There are two at the foundation box and the foundation tunnel. The one on the left, the foundation tunnel, has been put up because we've looked at schemes where the ground was very difficult, and we would drive those tunnels using a pressure balance machine. And having got the tunnels through, it allows us to use those tunnels to carry out ground improvement in the area where the arch is going to go. Because with pressure balance you can hold back any of the waters or the possible settlements. The jack deck concepts also lend themselves to all kinds of structures. There's the jack modular foundations with the jack deck like we used at Cliff's End. But I mean, for a station it's much smaller than the Cliff's End 20-meter clear span. Here you I think would want something about 10 meters, more than sufficient for most rail metro stations. And there's another alternative there, top box and piles. And here's finally our concept of how we would undertake a full metro station from the top. We would sink that central shaft, which is required for access anyway, and from there we would install the rest of the station by jacking, in this case, a high-level box and a jacked arch. And there is the concept that we're suggesting for metro stations, but you can apply these things in all kinds of ways underground. I mean, I set out a number here. And I've added, apart from the ones I mentioned earlier, I've added wastewater and water treatment plants, because certainly in a lot of cities, those plants take up a lot of room and are not exactly the ideal thing to have in a large urban center. And another one, they're doing this in Hong Kong, they put it in the refuse collection and disposal depot. So which is not a very popular thing, is rubbish trucks, you know, and the smells, etc. And by putting them underground, they've released land at the surface and also got rid of a not very pleasant environmental facility. And of course, a number of military facilities are conveniently put underground. The Swiss, where I live, like to put their aircraft in big rock tunnels underground to keep them safe. So there are just some of the ideas that we might use in the future, and we believe that we can now do this in grounds that you couldn't have done it with before. So I'm now handing it back to you for any questions, and I will try and answer them, Chris and I.
Okay, thank you so much, both James and Chris. I'm going to mute that line again. I don't think I mentioned, but both Chris and James are over in Europe in 2 separate countries, so that's fine. We appreciate your patience and bearing with us with some of the audio issues. We do have an opportunity for folks, if you have any questions or want any clarifications on things you've heard today, you can use the questions tab on that toolbar, and those will go directly to me, or the gentleman could follow up with you following our webinar. James and Chris, or James, could you give your contact information for folks who might want more information?
Yes, you can get hold of us, and probably the best way, but then you contact all of us at the same time, is go to team@jackstructures.com. Jack Structures, all one word.
Okay, so team@jacked structures.com.
That's it. And that gets through to Chris, myself, and my other colleagues. We're just a small group, but we're all pretty specialized in what we do, and we've been involved with these kind of structures for many years. Now, we have worked in the USA. It's not a new thing for the USA. We have done jobs. We've developed schemes for Port Authority, New York Port Authority, New Jersey Port Authority, get it right. We've also looked recently at a job in California. That didn't go ahead, but there's one or two other things, particularly in connection with the new metro developments, where we see great potential. It's just getting introduced early enough on, because unless we get our concepts in early on in the development, then we're unlikely. Somebody comes up with some idea, maybe based on box jacking, and they don't like to change when they've developed the whole scheme. Whereas we believe that if we can get in early, we can both save money and make a safer job.
James, we do have a question. Has this technique been used or considered, I guess, for underwater and submarine structures?
To some degree, yes. I mean, I recently was a joint author on a book for putting underground outfalls in under the ocean, and of course that is done by these jack methods. Under certain circumstances, it would be possible to put them in. Although I think you, in all fairness, you should realize that people are putting, they have methods of putting stuff in the bottom of the ocean or across riverbeds, which is fairly effective these days by trenching out and going across the riverbed. It's a question of pressure and the ground conditions, etc. You know, the pressure that's going to appear at the face.
Okay. Well, I think that's all we have for questions. And oh, wait. As soon as I say that, we get another one. At what rock strength, James, at what rock strength ranges would this be infeasible?
Oh, you are essentially trying to, one of the problems we have in working in rock is overbreak, because that will lead to settlement. I mean, it does anyway, but there are a number of things we would have to do. I mean, very good stiff rock we wouldn't consider, because it's cheaper to do it by the existing methods. But if we had, for instance, things like fractured rock or friable rock, then I think we're talking about possibly, with a certain amount of treatment in fractured rock, of creating a soil which is sufficiently homogeneous so as we don't lose it as we drive forward, and we are able to cut it. There's a whole lot of tools that we use depending upon the soil strength, and I mean, yes, you're not going to work in the granites and things, but you are going to be able to work in the schists and the softer things, softer limestones, etc.
All right. Well, I want to thank both of you, Chris and James. I also want to remind the attendees today that we are recording this, and we'll be posting it at www.fiatech.org, so you can get a copy and share it. I've had a few requests for folks that do want a copy of the presentation. So once again, thank you very much. We'll have that up in the next day or two, and I hope everyone enjoys the rest of their week.
Okay.
Thank you very much, Nicole.
Thank you very much to everybody for attending.
Thank you. Bye-bye.